Hi everyone. So for those who might be watching this outside of my classroom with a different teacher, just a quick introduction. My name is Miss Lorette. I teach math here in Cranston. This is my 5th year teaching here. And if you need me for anything, I'm in room 3223. So today we're going to continue with section 2.1, solving one-step equations. This is lesson 4, and I'm going to walk you through how to solve equations that involve multiplying and dividing with the use of a calculator. So you're going to want a calculator handy for today's lesson. Okay, so take a moment to copy the 2 examples that you see in your notebook. When you're ready to follow along with me, unpause the video and we will solve them together. So I'm going to start with the example on the left-hand side that says multiplication. So again, you can draw a line down your equal sign, just like you saw in previous lessons. It's just a nice visual. You don't have to do it. And the goal here is still the same as before. We're trying to isolate the variable with the use of inverse operations. So whatever operation I see happening with the variable, I do the inverse of that. So I see that there's a number touching the variable. That means multiplication. So I want to do the inverse of multiplying, which is to divide. So I'm going to divide by the exact same number that I see touching, including the negative. I don't change the sign here. So I divide by negative 0.4. These will cancel, leaving me with the variable. I bring down my equal sign, and what I do to one side, I must do to the other. This is a calculator-friendly lesson, so I'm going to use my calculator to get my answer. I take 1.36, I divide it by negative 0.4, and my quotient is negative 3.4. Careful with your signs. Also, careful with how you're writing your final answer. Notice that when I write my answer, it's not just a number, it's an entire equation. It's the number equals that variable. If you were ever unsure if you got the correct answer, again, you could do a check. You would simply substitute the variable with that number in the original equation and evaluate. And then if you got the same number on both sides of your equal sign, it's the correct answer. Okay, let's take a look at the example on the right. Again, I'm going to start by drawing my equal sign, or my line down my equal sign. And when I look at the side that contains the variable, I see division. So the inverse of that is to multiply. I'm going to multiply by the exact same number that I see in the division. So I'm going to do times 18 to both sides of my equation. They're going to cancel on the left, leaving me with the variable. And on the right-hand side, I can use my calculator to multiply, and I get negative 126 as my product. Okay, before we take a look at examples that involve fractions, let's review a key term that I'm hoping at some point you've heard. It's reciprocal. Now, many of my students in the past have thought that reciprocal means the same thing as opposite. These are 2 different words and they have 2 different meanings. Opposite means that you're changing the sign. So if something's positive, you're making it negative and vice versa. Reciprocal means you're not changing the sign, you're leaving the sign the same, and you are finding the multiplicative inverse of a number. The easiest way to say it is you're kind of flipping the number upside down. So take a moment to define this key term in your notes, as well as draw this table that you see here. The left-hand side should contain these numbers, and on the right-hand side, we're going to list what the reciprocals are. Okay, so as I mentioned, a reciprocal is a multiplicative inverse. When we think about inverse, think about the examples we just did. Okay, I'm going to grab my highlighter here. So this negative 0.4 canceled out with this negative 0.4 because the operations that we were using were inverses. So they canceled. Same idea here. If I find the reciprocal or a multiplicative inverse of a number and I multiply those 2 numbers together, they should cancel out. So let's take a look at the first one. 4/7. Well, if I flip that number over, that's just going to give me 7/4. Now, if I took 7/4 and I multiplied it with 4/7, If they are truly multiplicative inverses, they should completely cancel out. So let's just do a quick example here. Let's take 4/7 and multiply it with 7/4. If you notice, I've got 4's diagonally across from each other that I can cross cancel to give me 1's. I have 7's diagonally across from each other. They can cross cancel and give me 1's. So I'm left with 1 divided by 1, which is just 1. So the two fractions completely cross canceled with each other and left me with a 1. That means they are multiplicative inverses. Let's take a look at the next number. It's an integer, so it's not a fraction, but I can make it look like 1 by giving it a denominator of 1. You can do this with any integer. When I do this, it's very clear now what the numerator and denominator are, so it's a little easier to flip the number upside down. So instead of -5 divided by 1, it becomes 1 divided by -5. Notice how I'm not changing the sign when I do this. It's still a negative. And the last example, 1/3. Well, if I flip that over, that's just going to give me 3 divided by 1. And I don't have to write the denominator of 1. I can simply write this as an integer of 3. Now that we've reviewed what reciprocal means, let's apply that to one-step equations to isolate a variable. So take a moment to pause the video again, copy these two examples somewhere in your notes, and then we'll try them together. Okay, so I'm gonna again start with the example that's on the left side. I'm gonna draw my line down my equal sign, and when I look at the side that contains the variable, I see that the 3/4 is touching the variable. That means multiplication. So in order to get rid of this fraction here, I'm gonna multiply by the reciprocal of 3/4. And just as we saw in that example that I wrote in blue on the previous slide, the 4's are diagonally across from each other. Those two 4's are gonna cross cancel out. The same thing with the 3's. And by multiplying this fraction with its reciprocal, it completely cancels out, and now I'm left with the x. What I do to one side, I must do to the other. So I'm gonna multiply the left side by 4/3 as well. Positive times negative gives me a negative. When I multiply the two 4's, I get a numerator of 16. And when I do 3 times 3 for my denominator, I get 9. If you're utilizing a scientific calculator, your calculator might be giving you a mixed number here. That's totally okay. Mixed numbers or improper fractions, either are acceptable. So I'm gonna leave mine as improper. Okay, let's take a look at this example. So again, the 6/5 is touching the variable. That means multiplication. I want to get rid of that fraction, so I'm going to multiply it against its reciprocal, which is 5/6. What I do to one side, I must do to the other. So I'm going to go ahead and set that up. On the left side, the 5's are diagonally across from each other, so they cross cancel, as well as the 6's. These two fractions completely cross cancel, and I'm left with my variable. On the right side, I can cross cancel a few things also. I always like to cross cancel before I multiply. You can always reduce after, especially if you're using a calculator. Your calculator should do it for you. But I always like to cross cancel first if I'm doing it without a calculator, so that way I'm reducing smaller numbers. If you wait and reduce it last, you'll be reducing larger products. The 5's are across from each other diagonally, so they will completely cross cancel and leave me with a 1. I can divide 6 and 12 by 6, so 6 divided by 6 will cross cancel and leave me with a 1. So these are all 1's here. And then the 12 will reduce to a 2 if I divide it by a 6. In my numerator, 2 times 1 just gives me 2. My denominator, 1 times 1 gives me 1. I can leave it like that, or I can write it as an integer. Remember, any number over 1 is just whatever that numerator is. And there's my final answer. Okay, so at this time, go ahead and pause the video. Give all 3 of these problems a try in your notebook on your own. Then when you've given them a try, unpause the video and we'll go over the solutions. Okay, so at this time, you should have given them a go. Let's take a look at the solutions. For the first example, you should have divided both sides by -13. These are going to cross cancel, and I'm just going to double check really quick with my calculator. 104 divided by -13, you should have gotten -8 as your quotient. For the middle example, you should have multiplied both sides by 3.5. These will cross cancel, leaving me with the variable. I'm going to use my calculator to multiply here. 3.5 times 6.2, which is negative, and I get -21.7. And for the last example, you're going to need to multiply both sides by the reciprocal of 14 divided by 5, and that is simply going to be 5 divided by 14. Do it to both sides. The 14s cancel, the 5s cancel, and I'm left with n. And then on the right-hand side, the calculator I'm using is not so good with fractions, so I'm just going to do it mentally, but I encourage you to practice using your calculator right here, and especially if you're using a scientific one, practicing pressing that ABC button to input fractions. So if I cross cancel correctly here, and again, your calculator should be doing this for you, you should be getting 7/8. That's the fraction your calculator should be giving you. Okay, and that is my last slide. So that's it. So I hope that you found this helpful. Again, if anything is confusing here, I encourage you to go back to certain parts of the video and re-watch it. Also ask your teacher for assistance if you need it. And I'll see you guys next time. Bye.